and help us figure out what's going on inside the Earth. Seismic wave is an earthquake wave, and we can detect those using seismograph stations. We have seismograph stations all over the Earth. On your screen, you can see we have a representation of the seismograph stations, and the stations themselves jump up and cause some of these earthquake waves, and each one of these stations can cause waves, and they are detected by the other stations. The pink waves represent primary waves, or P waves. Primary waves can go through solids or liquids, but they change speed when they transfer from one to the other. The red waves, the S waves or secondary waves, they can only go through solids, so they'll bend back when they hit a solid. So let's take a look at this. What I'd like you to do is, if you see the waves, I'd like you to take your finger and point to the screen and follow these waves as we go. Okay, pick a pink wave, pick a primary wave, and follow its path as we go. Okay, so pick one of those. I'm going to choose the far left one, and it's kind of going smooth. Okay, I'll pick one more in a different spot and follow that wave. I'm going to pick the next one closest to it. This one goes this way. Ooh, it's got kind of like some wiggly stuff going on in the middle. So that tells me it's probably going through different medium, okay? Now we're going to look at the red waves. We're going to pick 3 of those to look at. We're going to start from the left side and work our way in. So let's start from the left side and see what the red wave is doing. Follow it with your finger on your screen. Okay, that made kind of a smooth arc towards that side of the Earth. Let's do the next red wave. Oh, that one's making a transition all the way past the next seismograph. Let's do the middle S wave. It's going down towards, oh, it went down towards the center of the Earth and then bounced back. So what can these seismic waves tell us? Well, let's take a look at them a little bit more closely. So we have our Earth with our seismograph, and we know that we followed the path of the waves, right? The pink waves went kind of like this, and there was one that went like this that had kind of some bumps in the middle, and then we had another one with some bumps in it, well, like a bump right here and a bump right there, and then we had another one that kind of went smoothly. Okay, our S waves, our secondary waves, there was a smooth one that bounced right back to the seismograph station, and then another smooth one and another smooth one. Okay. Without this information, if we were just like, okay, how many layers does the Earth have? Well, we could only say one, because we've never been to the center of the Earth. We don't know what it looks like. So we'd say, okay, there's at least one layer. So we're going to represent that with a green circle. Okay, we're going to start with one layer. We know that there's at least a crust. We are guessing there might be more, but there's at least a crust. Let's see what the seismic waves tell us in addition to that. If you look at all 4 of the seismograph stations, the S waves look like this. Okay, they go smoothly around the outside of the crust. That fits with our idea that there's at least one layer of the crust because these are going smoothly. They're not bouncing back. They're not going through a different medium. Okay, the inside ones look like that, still smooth. However, the last ones, from here to here, they bounced right back. Now remember, these are the waves that cannot go through a liquid medium, which means if it's bouncing back like that, what can we infer? Why is it not going there? Why is it bouncing straight back? There's got to be something different right there, right? Now, if we were to use this diagram, what can we decide about the Earth? Does it have another layer? Yeah, it's probably got a layer right there that these waves are bouncing back from. Okay, so we have 2 layers now. We have the outside of the Earth, the crust that we can see, but now the seismic waves are telling us there's something in the middle of the Earth too that our seismic waves are bouncing back from. They can't get through them. So there's at least 2 layers of the Earth. Okay, let's look at our P waves now, our primary waves. They had some nice smooth ones around the outside, showing they're probably not going through any different media, just nice solid right there. But then we have these weird squiggly ones. They had these 2 bumps in the middle. So we know that these waves can go through solids and liquids, so it would make sense if this was a liquid layer that it would go through it, but it changes its speed and that makes it curve. We're going to learn a little bit about that in 8th grade, why it does that. But when you have them, you'll notice that that second layer that we use the S waves to determine, those bumps fit right where the S waves told us they would be. So that's a confirming evidence that we have at least 2 layers of the Earth. Both P and S waves tell us that we have a second layer. But can they tell us something more? Well, let's take a look. If we use all of the stations, It makes this little star-shaped thing. And yeah, you can see that this circle fits right at the tips of where those are all refracting. So that's confirming evidence saying that, yeah, it looks like there is another layer right there. That's probably liquid because it's changing its speed. However, what about this in the middle where there are no waves going? What does that tell us? Well, there's probably something there too, which means we have a third layer of the Earth. So far, what we've seen is that we've got the outside layer we can see. We've got an inside layer that the S waves can't go through and the P waves bend. But then we also have this really center layer that none of the waves go through. So that means we have at least 3 layers of the Earth, and we can tell that simply by detecting the waves, the earthquake waves, that are going through the Earth. Anytime there's an earthquake anywhere on the Earth, we can feel the waves on seismographs all over the world. And that is telling us that's evidence that tells us what's going on inside Earth.